All right. Well, hopefully you are joining us here on Twitch. If you're seeing me, I guess that's a yes. Glad you're here today. I'd like to introduce you to Bob. He's here to my right. Bob Kinney is one of our SDEs for Amazon API Gateway, and he'll be joining us today for building happy little APIs. I'm so excited you're here. Today we're going to be diving in deep on troubleshooting, on fixing problems in API Gateway, fixing problems in our application, and how best to troubleshoot. And Bob is the expert on that. Bob, you want to say hi and say a little bit about yourself?
Sure, yeah. So, like Eric said, my name's Bob. I'm an SDE on API Gateway. I've been with the team basically since the launch of the service. Been with Amazon for a little over 7 years. And I'm really happy to show people how to use the services that we build.
Now, I got to jump in here, and I got to be honest. I was very reticent about having Bob on the show. One of the main comments I've been getting about the show, other than the technical acuity and ingeniousness that's happening here, is the beauty of my beard. And unfortunately, I will never come close to what Bob's got going on there. But I am jealous. But yeah, so it's a battle of beards here. So Bob, we are glad to have you. Excited. So what we're going to do is kind of jump in, and today is going to be mostly a live code day. You're going to see examples of code and how to approach different problems, but we want to talk a little bit about what services or what we're going to be dealing with. So this episode is called the All-Seeing Eye over Amazon API Gateway. And this is really looking at how to monitor, troubleshoot all the things. So last week, if you remember, when we had or last episode when we had George with us, we had a very simple architecture, and the architecture looked like this: you had your clients, you had an Amazon API Gateway, and you had a Lambda function. And we talked about how to build basically a simple REST API using proxy, using integration, different things like that. Today, we're going to take this and we're going to add on it a little bit to where it looks like this. And you'll notice that we've added to this one Amazon DynamoDB, which is NoSQL serverless database. And we're going to be using that to collect data. The second thing we're adding is Amazon CloudWatch and AWS X-Ray as kind of monitor over the whole system. And Bob will be kind of walking through that. But I want to kind of break down what are these services before we go too far. Amazon CloudWatch. It allows you to access all your data from a single platform. It's really the easiest way to collect custom and granular metrics for AWS resources. And I say custom because you don't have to just take the system's pushing data to CloudWatch, but you can also push data to CloudWatch as well, to trigger events, to trigger alarms, all kinds of things. It's visible across your applications, infrastructure, and services. And you can derive actual insights from logs. And Bob, we're going to look at some of the insights today, aren't we?
We are going to take a look at all of sort of the various aspects of this API.
Okay, so one of the cool things is the insights itself and the ability to build custom reports and things like that. Bob's going to be kind of walking us through that. But with CloudWatch, you're able to, again, do alarms, events, time-based events. There's just any number of things that can be done. The second thing we're going to dive deep into is Amazon X-Ray. And X-Ray is a fairly new service, been here about 2 years, and it allows you to review request behavior, discover application issues, and then it helps you find bottlenecks to improve application performance. It does a lot more than this, but it's a very powerful system. You kind of see the idea here where it gives me feedback. If I have a client that's hitting my AWS Lambda and then it's hitting the function, it's going to tell me, hey, the Lambda service itself, and you see by the example here, is 136 milliseconds, whereas the Lambda itself has a 3 millisecond latency or response time. And so great way to look at where are things happening. And then it also breaks it down. These are just quick examples of tracing and how that looks as well. So again, a lot of power here, and we're going to use these two services. And Bob, are we throwing anything else? Did I miss anything?
No, I don't think so. And if we did miss anything, I'm sure it'll probably come up in the demos.
Alrighty. So what we're going to do is as we find out a lot, it's hey, show me the code. So at this point, I'm going to turn it over to Bob. And Bob, I'm probably going to interrupt you with a lot of questions and stuff. So
Sure,
I turn it over
absolutely.
to you.
Okay. So Eric mentioned that it's going to be largely a live code. So this will be more, think about it as live ops. So one of my roles here at AWS and specifically on API Gateway is a little bit of an operations wonk. So I'm oftentimes the guy that gets called when there is a large scale event for the service and get engaged. So I am very focused on sort of how to figure out how do we dive deep into problem APIs, figuring out what the root cause is, finding mitigations for that root cause, and so that we can get the API back up and running at 100%. So what I'm going to try to walk through right now is sort of a simulated exercise that you as a serverless API owner might experience. So what I've got here open now is just a Gmail inbox. So I set up a test Gmail account for this purpose, and I've already got a a notification alarm from the CloudWatch service. So beforehand, I started up a load generator against my API and set up a CloudWatch alarm. And this is notifying me that this alarm is now in an alarm state and that I should actually take action on it. So I'm going to go ahead and switch over to my CloudWatch dashboard. So CloudWatch supports not only metrics and alarming as well as logs. They have this great little dashboard feature that you can actually build in a dashboard and track a bunch of metrics in a simple, convenient dashboard that you can quickly look at. So this is a very common practice that we inside of AWS use all the time. So when an operator is actually engaged on a problem, they go right to the dashboard and start looking at the metrics that are going to show the actual customer experience. And so what I've got here on my dashboard right now is just a few different graphs and an insights query that I'll get to in a second. And so the first graph that we see here is an RPS utilization graph. And this is a great way to kind of break down your account level usage for API Gateway. So API Gateway, by default, comes with a 10,000 RPS limit for an account. Now, that is a limit that is soft. We can definitely increase that. If you have workloads that are going to be higher than 10,000 RPS, please let us know. We'd love to hear from you. But within inside of that, you have your individual APIs could use a portion of that limit. So this is a nice way to kind of see if you had multiple APIs in your account, how much each API is contributing towards that overall goal. Then on my next graph here on my dashboard is the RPS for my little happy little API that I set up. As well as the 5xx and 4xx percentages that my API is generating. And so that my alarm was that I was receiving a high number of 5xx errors. So that just means that any status code 500 or above, API Gateway is returning that for my API. And so I can see that compared with an RPS rate for my API. So I can see right now that my API is generating 89% 5xx errors. That's crazy, crazy high. Then right below that, I have what we call a insights query. And so this is a query over access logs that will then pull out a subset of requests that are matching a query. And so this query is showing me all of my 500 requests for this API within the last hour. And so the most recent ones are queued up at the top. And so I can see the request time, the request ID, which is going to be the API Gateway request ID for this request, the status that API Gateway is returning, the integration request ID, which will be the Lambda request ID for this API call. That is, if we've made a call to Lambda, as well as the Lambda response code for my API call. So now that I have this information, I can say, okay, I have a request ID. Now, how do I figure out what's actually happening with that request? So I'm going to go ahead and grab that request ID, go ahead and copy it to my clipboard, and then I'm going to go over to the logs dashboard, the logs portion of the CloudWatch dashboard, and start looking for my request. So the first thing I'm going to do is I'm going to go to the execution logs for the API Gateway API. And I'm going to search my log group. I'm going to search for this event, for this request ID, making sure to enclose it in quotes, because otherwise CloudWatch will consider that a partial query. And we'll see, we'll get some live delay here. And so what I should be seeing here at this point, unfortunately I'm getting a little bit of a propagation delay, is the request ID, the logs for this request ID. I'll try grabbing a slightly older request so that we can get perhaps less of a chance of propagation delay.
Hey Bob, while you're doing this also, are you going to, or can you show us how you built one of those charts and graphs?
Yep, we'll actually be adding some additional graphs to this dashboard as a way to demonstrate that functionality.
Okay.
All right, so we are having some problems here. Okay. All right, so rather than trying to search by a given request ID, which unfortunately doesn't seem to want to work today, we'll go to one of our one of our log streams. And the API Gateway execution logs will log multiple events per execution. So this will give you basically a breakdown of the various transformations, authorization, throttling, etc. that might happen during the course of your API invocation. So I'm going to go ahead and look for this. Here we go. So here's one that's a 502. We're looking for a 500. Okay, so here we go. Here's a request ID with a 500. So I'm just going to grab this guy and quickly pull out just its logs. Okay, so now I'm just getting the logs for this request ID that generated a 500. Because I have extreme verbose logging turned on, so I'm getting what we call full request response logging enabled, I can see sort of everything that's happening inside of the context of my API. I can see that the what request is actually being sent in. So this is a weather API, and it takes as an input a zip code. Excuse me. And so then it passes that off to our Lambda function, transforms it into a format that our Lambda function will understand, and then hands it off to the Lambda function to execute. Then I can see the response as well, the full response from my Lambda function. So I can see here that Lambda returned a 200, but I'm using the proxy format that you learned about in the previous session of Happy Little APIs. And my Lambda function is actually telling API Gateway to send back a 500. So it is considering this a fatal error. And the error message, the body that's actually going back to the customer, just says that there's no results in my database for this zip code. Now that seems like an odd thing to return a 500 for. Normally you might expect that like an unexpected or a not found error would return a 400 class error or a 404 specifically. So let's just take a quick peek at this function code and see if we can figure out what might be happening here. So this is a really, really simple Python Lambda function that is querying a DynamoDB database based on the input that is coming in from our clients. And so you can see here that if I have a type error or a generic exception, or these are the conditions in which that the Lambda function would say generate a 500 for this API. And then if I scroll back up here, I see that my find data function is returning a type error for this error message. And so this is the bug in my code that is generating the 500 errors to my customers. So if I change this instead to a value error, save my function, kick off a build and deploy, while that's building, we'll talk about some other things. And so what should happen here is that I've made that change, I've deployed my Lambda function, and I should immediately be able to see a recovery in those metrics. And so instead of a 5xx error, my customers will get a more appropriate 4xx error, my alarm will clear, and my operator can go back to bed. And so that's how we can respond to sort of an event in the case of an alarm. So let's take a look at a little bit about how we actually constructed these graphs and how we can add additional information to our dashboard that will be useful for other kinds of operational events. So if I hover over here on any one of these graphs, I can go to the Edit button, which will open up an Edit tab in the CloudWatch dashboard, and I can see sort of the breakdown of what all of my lines inside of my line graph are. And so I have two here, or I have four metrics that are actually being graphed here. Two that I'm hiding, and then two that I'm actually showing. And so the reason that I'm doing that is because API Gateway emits a raw count metric, but I'm more interested in sort of seeing an aggregate RPS metric. And so I've added the count metrics both for my account level, so that's no API dimension, and then just the API that I am running against, so the happy little APIs. I then hide those metrics and then add what's called metric math graphs. And so these ones, I then just say, okay, these are 1 minute metrics. An average RPS for a 1 minute metric would be that value of that metric divided by 60. And so then I literally just say that the overall RPS is M1, which is our account level metric, divided by 60. Our happy little API RPS is the M2, which is our happy little API's API count divided by 60. And so that way you can easily get an RPS graph and then do whatever you would like with it. So that's that one. So let's take a look at this one where we actually have two different kinds of metrics. And you can actually already see that my 5xx's are starting to drop. My 4xx's are increasing, which is exactly what we'd expect for that change that we made. So on this one, I took advantage of the fact that we can actually have two axes on our graphs inside of CloudWatch. And so on our left-hand side, we have our RPS for our API. And on the right-hand side, we have a percentage of our 4xx and 5xx errors. And so again, I'm using metric math, not only to calculate the RPS, but then also for the percentages to make them a little bit more human readable and easy to read. So the metrics that we're actually looking at are the 5xx error and the 4xx error that are emitted by API Gateway. Now, for every request, we will emit a metric, either a 0 or a 1, if it is a 5xx or 4xx error. So if it's a 200 error, both of those metrics will be 0. If it is a 5xx error, if a 500 error, then it would be 5xx1, 4xx 0, etc. So what that allows us to do is say that if we average that metric, that is the percentage or the ratio of those metrics, of that metric that is for my requests that are coming in. So that if I multiply that ratio by 100, I get a percentage. And so that's all I've done here, is so I have my 5xx percentage, my 4xx percentage, and an RPS. And then these little y-axis knobs allow me to then push the RPS over to one side and the percentages off to the other.
So I'm going to interrupt you real quick here. And I know now because I asked you earlier and I felt kind of silly, but for other people to see it as well. In the details, you're doing the M2 times 100. Where does the M2 come from?
Right, so the M2 is our ID, which is literally just this little ID column in our dashboard. So whenever you add a new metric, it'll show up as a new M counter, and the expressions get these little E counters.
Okay, so the ID is automatically assigned?
Yes, actually, I think you might even be able to modify it. Looks like I can. I've never tried, but certainly if you wanted to do that, you could. But yeah, that's where those values come from.
Excellent. And then at that point, I can just do metric math in listing it out in the details. That's where it's going to figure out my algorithm, so to speak, to figure out what I want to show for that particular data point.
Yeah, absolutely. And so that you can set, so you can obviously graph the metric math, but you can also set alarms on metric math. So if you're looking for something where there's a high delta between two metrics, you can actually look at that. You can actually say that I want to alarm when the difference between two values is too high. And so that's actually a really powerful way to set up alarms if you're interested.
Yeah, definitely. So we had another question here and thought we could answer it real quick. So because the error code 500 was an odd error to receive, that's how we determined it was a change in the code that was necessary. And I'll jump on that. That was how we generated the errors. And yes, obviously he knew what the error was, but that's where you start. You know, you look at that and go, okay, what what are the errors, and you walked through what are the errors that I'm receiving, and what should I be seeing? And
Right.
so, and Bob, I don't know if you want to add anything to that, but as an example, he generated out of 500 instead of a 400 to show, that was a different type of error that we should be receiving.
Right, yeah. So it's more about sort of like looking at the status code and then diving where that status code is actually being surfaced.
Right.
So again, it was looking for that 500 error code, looking at the fact that I was returning that 500 from my Lambda function, and then looking at my Lambda function to then say, okay, what would cause my Lambda function to return that 500? Now, obviously, this is a little bit of a contrived example for sure. But certainly you can use that kind of methodology for finding sort of any of your errors. So it's look for a request ID that is generating a certain status code. Look for the logs for that request ID, and then figure out from those logs what is actually generating the aberrant behavior.
And when we're tracing this, we might climb into that a little more, right?
Yeah, so we'll talk a little bit about tracing within the context of some other stuff. But we'll get to that in just a minute. So the last thing I wanted to kind of quickly highlight before we start adding some stuff is how this insights part is actually generated. And so this is using CloudWatch Insights, which is this great feature that allows you to run basically SQL-like queries that against your logs, and it works really, really great against things like structured logs, which happens to be what our access logs for API Gateway look like. And so actually, I'll quickly kind of look at that first. So you can see here inside of the API Gateway state settings, the logging and the tracing functionality that I have available to me inside of API Gateway. So these top settings here are all for those execution logs that I was talking about earlier that we were looking at, where we actually see multiple log entries for every request, where we see the breakdown of the request as it flows through the service. We have a different levels that you can choose. So the error message, the error level logging will literally only log anything that is actually generating an error. And then the full request response logging, I have this turned on here for demonstration purposes. This is not something that I would necessarily recommend for a live API, just because the contents of your API may be sensitive, and API Gateway does not currently support any sort of mechanism for scrubbing that data. So bear that in mind if you're using this, but it is a great way to sort of quickly.
Hey, Bob.
Yes.
We're going to interrupt you real quick. The sound is really bad again. Oh,
Okay.
There it stopped. Put it out, guys, and I apologize. I'm getting a lot of complaints that it's almost too loud to hear him. Alrighty. Bob, are you with me still?
I'm still here. Can you hear me?
Okay.
Am I a little softer now?
Yeah, it sounds like we're a little better now. So, okay, I apologize for interrupting you. Yeah, let's try to continue. I apologize to the audience.
Yeah,
we're trying to get this fixed.
everybody. So I'll try to use my indoor voice rather than my outdoor voice. I do a lot of speaking, so sometimes I have a tendency to project. So I apologize for that. So just kind of like summarizing, these top section is for the request logs, and the full request response data is not something I would necessarily recommend for production APIs, but it is really great for using sort of in an event. So you can quickly turn that on. It's just a checkbox in the save settings inside of the API Gateway dashboard. So if you're literally in the middle of an event, it is something that you can use to try to more deeply diagnose a problem. Additionally as well, we also have what we call detailed CloudWatch metrics. So all of the metrics that I was showing on the dashboard were all API aggregate level metrics. And that's only because my API is really simple. It only has one method associated with it. If you had a more complex API with lots of methods and lots of resources, you can actually get the same sort of metrics at a per resource basis. So like if you had a different get or put method and you wanted to sort of see the breakdown of those, the latency of those, you could definitely do that. there is a cost associated with that, so that's something to bear in mind. So each additional method that you enable this on, that incurs a cost. After that is the access logs that I wanted to kind of talk about within the context of Insights. So I've enabled access logs, and I have a JSON format. Now this is slightly different than the default JSON format that you would get if you just clicked on this button. I've added additional logs, additional context variables from my list of available variables that are going to be useful for me while I'm debugging events. And so the things that I would be interested in are like things like our response latency, our integration latency, as well as the integration request IDs that we saw earlier when we were looking at the 5xx errors. So because I have this structured format where I literally have a field name and then a field value, CloudWatch Insights is smart enough to actually figure out what all of my variables are. So when I'm actually running a query against them, it auto-discovers all of these fields that I've put in my access logs. And so
that'll still work with XML or CSV, right?
Yeah, so I'm not sure about CSV.
Okay.
So because the information is not encapsulated in every log line, so XML would definitely work because again it would follow that sort of format where each tag would be visible inside of the individual log entry.
Okay.
CSV might have to actually provide a format as part of your query to say that field 1 is X, field Y is field 2 is Y, and so on. But with this format, with the JSON or an XML format, Insights is able to auto-discover those fields for us. And so literally all I'm doing here is actually saying, okay, my status code, I want it to be a 5xx, so that's literally just a regex with 5 followed by 2 digits. Then I use this pipe character to say that I want to select only a certain number of fields. I want to sort those results by the timestamp, which is the timestamp associated with the actual log entry, and then limit those results to about 200. So that'll basically just give me the top 200. And so literally I can modify this query if I want. I can add additional fields and then save those changes to my dashboard. But what I'm actually going to do now is go ahead and walk through. So now our API is stable, at least in the sense that it's no longer generating 5xx's. But we want to understand a little bit more about sort of the customer experience. So like how fast is our API operating? So what I'm going to go ahead and do is actually add some graphs that will reflect the customer experience for our customers calling our API. So I went ahead and created a new widget, a new line widget, and then I'm just selecting metrics that I'm going to want to include in my graphs. So I selected API Gateway. I'm going to select the by stage because I'm only interested in my prod stage. And then I'm going to be grabbing the 2 latency metrics that API Gateway publishes. So there's an important distinction with these 2 metrics in that the latency is the time from when API Gateway receives the request until it generates a response. Now, obviously, on the back end, there could be a lot of stuff going on. That could include doing an authorization check. That could be calling the integration, which is what we're kind of interested in here. So calling our Lambda function. And so we've broken out the integration latency so you can kind of see the difference in sort of where the time is going. And so in this case, our integration latency is roughly going to be analogous to our Lambda duration plus Lambda overhead.
So this is from when it leaves the back of the API and hits whatever service, Dynamo, Lambda, whatever.
Yeah, so it's literally just the time from when API Gateway sends the request to the integration, in our case Lambda, to when it gets a response back.
Got it.
And then again, I'm going to graph this with my count, because again, I'm going to be interested to see if there's going to be any changes in the latency as the call rate goes up or down. Again, this is a very common practice that we use inside of Amazon. I am again going to turn that count into an RPS. So that's 3.
So you had to hit add math expression for the IDs to show up.
Oh, okay. Sure, I probably hadn't noticed that before.
No, yeah, you probably do that without thinking. So yeah, that's something to note. If you don't see the IDs pop up, hit the add math expression, and that gives you the options, obviously.
Okay, and so then we're going to do M3 divided by 60. And I'm going to make sure that we turn all of our metrics into 1 minute metrics. 1 minute metrics is the finest granularity that API Gateway currently supports for metrics. So there are options for 1 to 30 seconds. Unfortunately, those don't function correctly inside of the console. Okay, so that's our RPS. We're going to hide our count. We're going to move our latency graphs over to one side. Then I'm going to go ahead and say my left axis is RPS, my right axis is latency, and that's that. And so I'm graphing the average latency. Now I'm actually going to go ahead and change that before I put it on the dashboard. So the average is a good representation of the average experience, but oftentimes, particularly internally in Amazon, we often think about what we call percentiles, and so that just is sort of outlier requests. And so we often usually target the P99, which is sort of, you can think about it as the maximum request time or the maximum of a value after you throw away the top 1% of the outliers. And so API Gateway metrics for the latencies actually, and I need to turn this to a sum first as well, and support the percentiles. So I can actually also create custom percentiles, but CloudWatch has given me this nice handy dandy P99 value, so I'm going to go ahead and select that. And so now I can see sort of the P99 value of my API request rate.
So this represents, with the P99, this represents 99% of our calls, but it threw away kind of the highest and lowest.
It threw away the highest. Okay. So it's throwing away sort of the highest 1% of the data, because so your low values, your really fast values are going to pollute your average just as much as your high ones are. But
Gotcha.
this is just, think about it again as like the maximum after you've discarded some amount of large outliers.
Okay.
And then I'm going to go ahead and give this a name. So this is RPS versus API latency. And go ahead and create this widget. Give it a little bit more space. And then always the number one thing that even sometimes I forget to do is make sure to save that dashboard so that you don't lose those changes later. So now I have a latency dashboard that I can look at inside of my API. And so you can see that my P99 is actually pretty darn high. So that's like 300 milliseconds, three seconds. And really all I should be doing is querying a database to return some weather data about a locality. So that seems awfully high to me. So let's go ahead and add another widget, which will give us some request IDs that are showing high latency. So we're going to go ahead and select a query results. And I'm going to make sure that I select my access logs. And then I'm going to save some time and select a query that I've already pre-built. And so again, just going over this query again, I'm looking at the latency value, and I'm going to be looking only at the things that are where the latency is over 1,000. So the metric is recorded in milliseconds. So this is requests that are taking longer than 1 second. And then I'm going to pull out a few key fields that I'm going to be interested in my API. So the request time, the request ID, the 2 latency values, the 2 request IDs, and then finally this little guy right here, which is our trace ID. So this is going to be our link into quickly finding a trace inside of the X-ray console. So I'm going to go ahead and run that query. And we can see the results. And I'll go ahead and create the widget and add it to my dashboard. And so now I have this quickly available to me if I wanted to take action on it. I'll once again make sure that I save my dashboard. And And actually, before we dive into the X-ray stuff, one more thing that we should probably talk about is how we can set up the alarms after we've set this up. So under the Edit tab, I don't have the additional actions. I only can sort of add metrics and modify them. But if I go ahead and say show this in the metrics console, I have this nice little new icon for a bell. And so any one of these values, I can click this bell icon and actually set a new alarm. And so that'll be on the alarm on that metric. So I'm looking at the latency, I'm looking at the P99, I'm looking at a 1 minute period, and then I'm interested in when I want to alarm on that value. Now my query that I'm looking for in my dashboard is 1 second. So that seems like a reasonable threshold to go ahead and set as my alarm threshold. Under the advanced configuration, there are a few other options that are particularly useful if you're using percentile metrics or things that might not occur very often. So you can treat the data as missing, not breaching. I usually tend to choose not breaching, so sort of the no news is good news kind of situation. So you'd want to, if your alarm, if your API is not getting called, it's not going to fall over. But obviously, if you have a use case where if you're not receiving API calls, that is an event you want to take note of. You can obviously treat missing data as breaching. And then additionally as well, for the percentile metrics, there's an evaluate or ignore. So typically when you're talking about percentile metrics, you need to have enough requests for it to be able to calculate a proper percentile. If you don't have sort of that data, that RPS rate drops low enough that there's not enough data points, you can either, again, decide whether or not to evaluate that or not. I'm going to leave it that as evaluate. Then from my alarm, I have the ability to trigger an action. And so I'm going to say that I want to send a notification to my SNS topic, which is wired up already to my email address that I set up for the demo. And so it just shows up in a dropdown, and then I can see all of the emails addresses that are actually notified on this notification. Because it is going to an SMS topic, you can link that topic to anything else that you want. That could be an SQS queue that you process later. That could even be a Lambda function if you wanted to sort of have an automated mitigation. So if you knew sort of a common pattern that happened in your API and an easy way to mitigate it, you could even try to automate that with a Lambda function. I'm not going to add any other additional actions. And then I'm going to call this happy little APIs latency P99 and create my alarm. And so there we go. So now I have an alarm, and we already know basically based on our data that eventually this is eventually going to fire. Right now, because it's too new, it's showing this insufficient data state. Eventually, it will fire, and I'll get another email in my account telling me that my API is pretty slow. Okay, so now let's go back over to our dashboard. So now that I have these requests and these trace IDs, now is a great time to go over to the X-ray console and actually see a breakdown of my API and where we might be going wrong. So I'm going to go ahead and take one of these trace IDs. Hopefully we won't get a propagation delay again. So go ahead and open up the X-ray dashboard. Go to our traces. And you can already see a bunch of traces already. I've enabled a 100% tracing rate in my API. That may not be something you want to do in a production level API. You may only want to sample. So by default, I believe the default is 10%. But you can configure that however you choose. You can even choose different sampling rates based on any number of factors. So I'm going to go ahead and take this trace ID, and boom, we got it. Great, perfect. And so now I can see inside of my trace ID a breakdown of sort of all of the in-between steps of my API. So by default, if you just enabled tracing on your API Gateway API and your Lambda function, pretty much all you would get would be these top two subsegments. So you would see the API Gateway stage and the AWS Lambda. And so we can see that our request is taking 3 seconds, and then it's invoking the Lambda function. Again, the Lambda function is still taking 3.2 seconds. So the front end is not the problem. We're not having any problems with sort of the Lambda service overall. So how do we figure out where we want to go from there? Thankfully, the X-Ray team actually built this really handy SDK that you can actually drop into your Lambda function. And they actually have common SDKs for a lot of the popular runtimes, so Python, Node, as well as Java, that you can just kind of drop into your API, your function code inside of Lambda, and get these great little subtraces or subsegments inside of my trace. So I can see that inside of my Lambda function, the initialization took about 444 seconds. That's something that we don't really control 100%. We can do some optimization to try to improve that by increasing our pack size in our Lambda function, but that's not really, doesn't seem to be the majority of our latency. So where it seems to be most of it is the validate and prep method, or the subtrace in my function, as well as the find data scan, which is taking 500 milliseconds overall, and calling DynamoDB taking 400 milliseconds. Now, this feels like an awfully long time again, so remember that my API is taking in as input a single zip code and returning the results of that zip code, or weather from that zip code, back to my caller. So it seems awfully odd that we would, one, that we would take 400 milliseconds to return, and two, that we might be using this scan operation. And then additionally as well, we might want to take a look at this validate and prep method for potential bottlenecks or bugs that might be causing some thread contention or something else. So let's go ahead and switch back over to our code and quickly take a look at these two functions. So first, let's take a look at our scan function. Again, it's really straightforward, really simple. All I'm doing is using Boto to actually scan the DynamoDB table. And I'm doing a scan and looking for a field that matches my zip code. Now, I've got zip codes for every zip code in the entirety of the United States. That means that every time I want to check to see what entry to look for, I'm actually scanning over the entire table. So that's really inefficient. So it's really inefficient use of DynamoDB throughput because every one of those items that is checked is going to count against my provision capacity. And literally, I'm going through all of those entries every single time. The table was actually set up such that it was where the zip code was actually the index. So there's far more efficient ways for us to actually get that data out rather than doing a scan. And again, apologies for a bit of the contrived example, but we do have a sort of an example code here where we can actually change this so that we would actually use a more efficient algorithm to actually get that data out. Where rather than using a scan where it would actually have to read through the entirety contents of the table, I can just do a get item. So I'm literally just going to DynamoDB, telling DynamoDB, give me this one item and only this one item if it exists, and then return that back to the user. So that'll be a much more efficient use of time and resources. So I'm going to go ahead and make a small change to say, use the find data get item method instead of the find data scan method. And then I'm going to...
Can I interrupt you? Yeah, I was just going to say, can you explain the X-ray recorder.capture call that's right above that?
Sure. So that's actually the X-ray SDK. So that's the method that you can use to easily annotate the subtraces. So you'll see here that these captures with the data are exactly what shows up in the X-ray console under my subtraces. So annotating these subroutines or functions basically allows me to say that I want to do a subsegment trace over that function. And so you can also do, if you don't want to annotate the function, you can also do an explicit start trace and stop trace inside of a function if you wanted to get even more granular on top of that. For these purposes, it was really useful for me to use these annotations. Okay, so let's take a look at our validate and prep. Again, I apologize, but the contrived examples are really easy to show and really easy to demonstrate. But I can see right here a real glaring red flag that says this is where my time is going. So I'm literally have some random sleep baked into my function so that I sleep a random amount of time somewhere between 100 and 2,000 milliseconds. So obviously that's not going to be a very efficient use of our time. Lambda bills based on our execution time, so I'm literally throwing pennies away. So I'm going to go ahead and comment that out.
Bob's code is so good, he actually has to actually write in issues.
Yeah, I wouldn't go that far, but at least for today, that's where we're going to do. We're going to say. So now that I've go ahead and made those changes, I'm going to go ahead again and start up a build, package, and deploy step, which will deploy those changes back out to Lambda. And I should hopefully see a pretty much almost immediate change again in my metrics. And so while I'm waiting for that, I'll kind of walk through some of the stuff inside of the X-Ray dashboard that might also be of interest. And so you saw this in Eric's slides at the very beginning, but this is what X-Ray calls the service map. Unfortunately, my API is very simple, so there's not a lot of different paths through my graph, but you can quickly see sort of the breakdown not only of errors, but like time spent, and you can actually change the period of the traces that it's looking at over time. So right now I'm only looking at the last 5 minutes, but this yellow line is an indicator of where errors are occurring. So you can see that API Gateway is generating the errors. And so again, that's because my Lambda function is saying API Gateway return a 400 to the caller telling them that they've sent bad data. And we can tell that largely because the green circle is, the Lambda circle is 100% green. So Lambda itself is not generating any errors. API Gateway is. It's another partial indicator that is going to be the cause of our potential problems, or where to look for where there might be potential problems. If I select any one of these, I can get sort of a breakdown with some additional graphs. And then the thing also to notice is you can see sort of the average latencies within those traces. And so if I start looking at, for instance, the last 1 minute, I can start to see already that the times are actually already dropping, even from the X-ray perspective. So the tracing is happening on 100% of requests. If I move that out to 5 minutes per se, you can see that there's a higher latency on these requests over the last 5 minutes than over the last 1 minute, which means our 1 minute is even better. So then if I go back over to my CloudWatch dashboard, so you'll see a couple of a really interesting effects. So my load generator is a single threaded application, and so it is sending a request, waiting for the response, and then sending a next request. I improved the latency so much on this API by switching to the DynamoDB get item and by removing that sleep, that I'm now actually generating 4 times as much traffic from that single thread because it is getting responses that much faster. So you can. Yeah, so you can see the latency drops pretty much through the floor. The RPS goes up because our load generator is getting faster results. And so that was pretty much all I wanted to talk through today. So it gives you hopefully gives you a good basis for sort of understanding how you can build monitoring, alerting, and diagnose problems using the AWS tools to improve your API's performance and reliability. So with that, I'll hand back over to Eric to finish this out.
Awesome, thank you. So, one thing is we might have to apply X-ray to our sound system here. I apologize for the sound issues. Hopefully you were able to hear Bob's, as he was walking through that. The bottom line is when you employ tools like CloudWatch and X-ray, and you start looking at why your application may be working. Now, originally it wasn't working, and Bob was getting a 500 back, and then he was able to do some editing to get it to be a 400, which was a proper response for not finding the right data, but it's still a working API. However, as you start to look at bottlenecks, you realize what you saw something like a 4-time increase or up to 4,000 mils. Anyway, a large increase on the throughput with a huge decrease on the latency. And so, the more efficient your applications get, obviously, the less money they cost, the more they're responsive to your customers. And so, it's when an application isn't necessarily broken, it can still be improved upon. And I would really encourage you to look at these tools when you use an API gateway, and even when you're using, some of the subsequent systems, because CloudWatch and X-Ray are going to work through Lambda, DynamoDB, and many other services. Bob, I really appreciate you taking time to walk through this. Actually, Bob's going to be joining us in 2 weeks as we continue our series. The next thing is security. We're going to talk about shut the front door. We've actually broken security down into 2 things. This first one is shut the front door, securing access to Amazon API Gateway. And we're going to be talking about how do you lock it down? How do you protect your API Gateway with services like WAF and IAM and different things like that. Sometimes, and man, as a developer, when I first started developing, CORS was a pain in the rear, and guess what? It still is. It's CORS is a tough thing, but Amazon API Gateway helps you out with that a lot. Different things like, again, locking down your security. So I encourage you to join us. We will be, again, that date, let me go back here, is May 28th. Same time, same place, different room for Bob. So we shouldn't have any sound issues. I apologize. We had that squared away until apparently right as it started. So we'll be starting that. Again, I'm Eric Johnson. You can find me at EDJ Geek. And this is Bob Kinney. And say that handle, Tarakma?
Tarakma is how you pronounce it. It's a garbled bunch of characters, but I usually pronounce it Tarakma.
Okay, Tarakma. And you'll have to ask Bob how he came around to that sometime. Guys, I appreciate it. I hope you have a great day, and thank you.
Yeah, thanks a lot. See you in a couple weeks.
Bye, guys.